mile worth of short ends, because they don't want to use them. They don't have a way to get rid of them. Your cable TV company can be your best friend, your worst enemy, and a good buddy all rolled up in one. Okay, charging right along. Some are buried, some are strung aerially. I have some of each. It's actually the same stuff. They just stuff it in the ground sometimes. Yes. And they usually use something called 7/8 inch, which is enough. The only reason you would dare use it is because it was free. And, well, I'm cheap. And it's effective. Okay. So, if you've ever played with radios, and you're sitting there and you have two radios in front of you, and you transmit on one, all of a sudden, if you were listening to something on the other one, it goes away. This is called desense. This is because the amount of transmitted power is so overwhelming the receiver on the other one that it can no longer receive the signal that it was trying to hear. Now, imagine trying to transmit and receive on the same antenna rather than one that's a foot apart. This is a n-squared problem. Further you get apart, the less power there is. And eventually, after 4 or 5 foot with little HTs, you can once again hear it. The distance is 0. I'm transmitting and receiving on the same chunk of wire. Thus, we're inventing these wonderful things called duplexers, or cans, or resonators. They're called cans for one reason, is it looks like 4-inch wide soup cans. That's just what it looks like. They come in various sizes. They are band specific, so if you are working on 50 megahertz, i.e. the 6-meter band, you will find cans that are as tall as I am, because they need to be a quarter of a wavelength long. If you are working up in a sane and reasonable band like 440 megahertz or 70 centimeters, you will find cans that yay tall. If you start stealing stuff out of cell sites that you've purchased and retuning them into the 900 megahertz band, they're tiny. And it goes down from there. Okay. They're tuned cavities, which means that there's a chunk of metal that you can screw up and down inside the middle of this, which resonates on one frequency. And since it resonates on one frequency, that is the frequency that goes in one side and comes out the other. And all the other frequencies are rolled off. And you can't hear them as much. This is very much like if you've ever played with a DJ mixer, the mid-pass setting. Excuse me, the voices in my head are getting to me. If you've ever played with a DJ mixer and you grabbed the mid knob and you tuned it back and forth and you heard different ranges of the mid-tones coming back through, this is what a can does for RF. Now, since you have that ability, go. Yes, which is an advantage for reasons I will get to shortly. So I can tune it on one point. Most cans also have something called band reject, which is an anti-resonator, which means I can say, pass this area, but really don't pass this area. So with the typical setup of 4 cans, which is 4 resonators, 2 on the receive side, 2 on the transmit side, I can put enough separation between the two that I can receive on one frequency and transmit on one 5 megahertz up, and they don't see each other. The transmitter is not feeding into the receiver because the receiver CAN pass is specifically set up to reject everything from the transmitter. And the transmitter, we usually tune it this way, but there's no reason to, rejects the receiver's frequency all the way around, which has the added bonus of when we're transmitting out, if there's any problems with the transmitter throwing out energy on the received frequency, the cans cut that frequency out as well. This is straight up frequency division multiplexing. This is one method of doing it when you have a single antenna. This is not how your cell phone company does it. They have an entirely different method. And modern cell phones go off in an entirely different direction. But we're not talking about cell phones, we're talking about amateur radio. Okay, I'm not understanding the question. This is probably because I'm half asleep. Oh, the tolerance. I'm going to be honest. We don't care. We tune it to the center. Okay, it's wide enough to pass a narrowband FM signal through, which means it goes 5 to 10 kilohertz each way with an acceptable roll-off, with effectively zero roll-off. We don't care past that point. I have cared. I need to sit down and do those numbers for any given model, but it varies by model. Usually, the first response to your question would be about a quarter turn, which is how far I have to turn it before it falls way out of alignment. Now, no, tuning cans is a process of taking a screwdriver, putting it in a slot, staring at a monitor, lining it up, pulling the screwdriver off, getting a readout, putting the screwdriver back on, guessing, pulling the screwdriver off, seeing if you guessed right, doing it again, and this can often take hours because you have 4 of these to do and they interact with each other. So you don't actually tune it correctly, you tune it to within epsilon of correctly, and then you walk away, lock it down, and pray the temperature doesn't change on you. It's called a repeater shed and a heater. And if your repeater is in heavy use, the repeater will heat itself, because it's going to be dumping a whole lot of waste heat. They all, after a certain level of repeater, they all dump waste heat. Okay. Hello. We would, except that we're out in the middle of nowhere where I do this stuff, because for some reason municipalities, people don't like seeing 200-foot metal structures rising from the side of people's houses. I think they're beautiful. I don't know what their problem is. Okay. Why? I am being failed. This probably means I can't edit a text file this morning. Okay. Radios. These are the last components that you desperately need to make this actually happen. You need 2 of them, because like most radios, they can either transmit or receive, but not both. And now you have to do it at the same time. Here's where it gets fun. Grab the busy light off the radio you're using to receive, tie it to the line marked push to talk on the radio you want to transmit on, and you have a repeater. It's not legal. It's got some major details missing, but it will work. We have done this for testing. Don't try this at home. Understand what you're doing in advance. Now I'm going to yammer on about radios. So we need 2 radios. One of them only receives, one of them only transmits. This means that you can now specialize your radios to one purpose, rather than having a transceiver that needs to do both, because you're going to key down, talk, unkey, and wait for somebody to listen. You can go get a high sensitivity receiver and put it in for the receiver role, and all it has to do is receive. In the same sense, I can go get a very high-powered transmitter that has no receiver stage on it and use that. Our personal favorite right now, we like taking what used to be paging transmitters and turning them into amateur radio gear. I'm staring at the time, okay, I have enough time to make a side story. Side story, I get a call one day. Hey Jeff, would you like to go pick up some radios with me down in Detroit? I live in Lansing. This is about an hour from Detroit. Sure, when are we leaving? Saturday morning, 6 a.m. Why do you guys always do this so early? Well, come on, get up. We get up early. So I do it. I dive into the vehicle. And I get there. And we go over and we pick up the truck with the trailer attached. At this point, I realize I'm getting in over my head. We drive down to a paging company in Detroit's site, where one of our contacts has been very carefully scavenging paging hardware that has to be thrown out and placing it so that we can park our vehicle next to the dumpster and miss. That day, I personally moved 3.5 tons of radio. I was hurting. Excuse me for a moment, I need water. Okay, so 3.5 tons of radio. This was in the form of 17 racks, each one weighing 500 pounds, which was an entire paging site that got ripped out of some county in Michigan because they were all upgrading to 900 megahertz, so we were getting all of their 70 centimeter gear, or as they call it, 460. Well, you grab the knob and you twist it, and, hey, that's funny, it goes down into the ham band. Great! 250 and 350 watt paging amplifiers. They're designed to run 24 hours a day, 7 days a week, until they run out of power. Or the universe collapses. One of the two. We got these for a song, a dance, and an agreement that we would turn them into amateur radio gear. This is how you do radio on the cheap. You find friends in the commercial communications industry and say, hey, I know you're throwing stuff out. Oh yeah, as a side effect, that 3.5 tons of radio, and another 500 or 600 pounds of hardline, and forklift load of cables, connectors, parts, adapters. You walk into a ham shop and there's $3 an adapter. I get a shovel out and I just shovel them. It was that bad. We just had a shovel and we were moving them because they were all laying on the ground, and it's sort of like, yeah, just pick those up. Pick them up? Are you nuts? Got a shovel out and just shoveled them all into the truck. And this guy, when he says, take it, you don't ask what it is. You don't wonder if it's worth taking. You just pick it up, throw it in your truck. It's out of his hair, and now you get to figure out what it is. Which is another interesting story of the cell site that showed up at a friend's house, but we'll be going, if you want to hear that, talk to me later. Okay. Aside complete. I hear a question. I hear a question. Does anyone find this, would anyone find it useful if I made a random diagram at this point? Big blocks, lines between them. If anybody wants me to, speak up now. Otherwise, you aren't going to see that I can't draw. Details. These are all the other pieces that you desperately need to make this actually work in a way that doesn't suck. There's this invention device object called a repeater controller. Its job is to, rather than wire the busy light from one radio and into the transmit button on the other one, and then you just connect their audio, its job is to process this audio and do sane and reasonable things to it. It can do useful operations like put your FCC mandated call sign on the air every 10 minutes like you have to. This way you remain legal and the FCC doesn't come knocking on your door with a bad attitude. It can do things like shut down half of the repeater so that it no longer transmits because it's decided to do something horrible and wrong. You have to deal with it. It can interlink audio from multitudes of repeaters to each other, which is a neat trick, which allows you to do things like link to other repeaters. So here's one repeater, and I can now teach it to link to another repeater, and now you have two repeaters that are sharing the same audio, sharing the same information, and you've just doubled your coverage area. This is one of the repeater networks I work on, which is slowly consuming the southeast, now moving towards central and northeast sections of Michigan. We can, with a little cheat sheet where we write down all the frequencies, wander anywhere from Detroit to Eagle. Detroit to the west side of Lansing. Grab an HT, choose a channel, and we are on the same repeater network talking to the same